All right, so we'll go ahead and get started here. So what we're going to be looking at today is section 5.2 in your book. This is a topic called strong induction. Okay, so we're on the second section of induction. We still have a little bit more to go. I think that we're not going to get through this section today. I think we'll get through the lecture material, but I think we might have to do some supplementary problems in another video because I don't want this video to go too long. So yeah, so let's go ahead and get started. So what is the idea of strong induction versus regular mathematical induction? So let's just remember what we know about regular mathematical induction. So with I'll just say mathematical induction, then what you have is you remember how this goes. You have a base case where you start. So like you show like P of 1 is true. Okay? And then that's your base step. And then what you do is you need to show that if P of k is true, then P of k plus 1 is true. And then you conclude P of n true for all n equals 1 to ... right? And that's regular mathematical induction the way that we did it in the previous section. And so I didn't write it, but this is your basis step, this is your induction step, and this is your conclusion. And then specifically, this part right here is your induction hypothesis. Okay, so if P of k is true, then P of k plus 1 is true. And so there's a small issue with that. So the problem with standard induction for some proofs, I mean, it works, so there's nothing wrong with it. But the problem with standard induction is that the if P of k true, then P of k plus 1 true step can't do every proof that we would like to do. So it can't be done for every type of proof. Well, I mean, of course, it can't be done for every type of proof. There are induction proofs that it can't be done for. So for some proofs. So you'd like to use induction, but you can't because this part right here is not going to be strong enough. Okay, and that's why we need strong induction. So the way to fix that is this way. So we use, that's a highlighter. We use strong induction. And so here's what strong induction says. So I'll write out base case now. Or yeah, basis, what do we call it? Basis. No, we didn't. Okay, base case. What's the base case? So you're still going to show P of 1 true, or whatever it is for the first number that you need to check, show that it's true. But for the induction step, it's a little bit different now. So you assume P of 1 holds, P of 2 holds, ... up to P of k holds, which means they're true. Then you show P of k plus 1 is true. And that's it for the induction step. So then you can conclude. I usually say conclusion, don't I? Conclusion, P of n true for n equals 1, 2, 3, dot, dot, dot. All right, so what's the difference? Right, the difference is right here, we're assuming P of 1 through P of k are true, as opposed to up here, where you're just showing, where you're just assuming P of k is true, right? If P of k is true. So it's the induction hypothesis is different. That's what's different. So the induction hypothesis is not assume P of k true. It's assume P of k, P of k minus 1, P of k minus 2, all the way down to the first one are true. I don't know why I wrote that backwards there, but let me just finish writing this and I can say something. Okay. So right here, the assumption is P of k down to P of 1. Here I wrote it P of 1, and then I counted up 1, 2, 3 up to k. Here I wrote it P of k, and then I counted down k minus 1, k minus 2 to 1. Of course, those are the same, right? That doesn't make a difference. So what's different is you're assuming all of the pk's, or sorry, all of the pn's k and smaller than k are all true, as opposed to just the P of k, right? The reason you need this is you need it, for example, to do proofs about Fibonacci numbers is one of the examples, and that kind of thing. So I think we mostly do Fibonacci numbers in the next section, though. Let me just double check that. Yeah, they do Fibonacci numbers in the next section. So maybe I'll save it to there. But yeah, so that's strong induction, and there doesn't really need to be a lot of explanation for it. It's stronger assumptions. So if mathematical induction worked for weak induction, which is standard induction, then it ought to work for strong induction, because we're adding more assumptions, right? So if it used to work and then we made it more likely to work by adding more information, it should be okay, right? So there's a couple of kind of weird problems in this section that they want you to sort of become familiar with here. So first one is what they call like the stamp problem, which I have typed up examples, but I'm gonna write out by hand as well. So let's look at those. So let's look at stamp problems. Just trying to help you guys mail in your ballot. Stamp problems. What's a stamp problem? Okay, so a stamp problem is something like this. They'll say, so they give you two denomination of stamps. So you're given, I'm going to explain it before we do the proof. So you're given, it's like two denominations. This works for money as well, but it's easier to do stamps because you can do stamps of any value, whereas coins are kind of generally even values. So you're given two denominations of stamps, like, well, what are they? Well, they don't have to be anything in particular here. I'm just going to come up with a couple of numbers. I'm going to do 3 and 5. I think that's in the homework, but I don't care. Like 3 cent and 5 cent stamps. All right, so let's just say that's what the post office sells. 3 cent stamps and 5 cent stamps. kind of low value, but it's easier with smaller numbers, and that's why I'm doing that. So you're given two denominations of stamps, like 3 cents and 5-cent stamps. And so what's not immediately clear here is that you can actually make any postage over a certain amount. So you can actually make any postage uh, of 8 cents or more out of these stamps, just using these stamps. More than one stamp, but just these values. Okay, and that's kind of the point of these problems is to show that. So, like for example, to make actually, let me erase this. For example, if you wanted to make 8 cents, the way you could make 8 cents postage is you would just use, well, what would you use? We have 3-cent stamps to use, and then we have 5-cent stamps to use. So if you were trying to make 8 cents, what you would do is you would just take one 3-cent stamp and one 5-cent stamp. So you would just say that that's going to be like 1 times a 3-cent stamp plus 1 times a 5-cent stamp. And that would be 8 cents, right? And then how would you make 9 cents? Well, the way you would make 9 cents postage is, it would take a different number of stamps. But what you would do is you would use 3 of the 3-cent stamps, right? So you just have, stamp, 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 and that would be your 9 cents. Whereas for your 8 cents, you would have a 3 and a 5-cent stamp on your envelope or whatever. Well, how would you make 10? Well, to make 10, that would just be 2 5-cent stamps. So you'd have a 5 and a 5. Oops. Okay. Well, how would you make 11? Well, you would need actually 2 of the 3-cent stamps would give you 6, and then 1 of the 5-cent stamps would give you, what would that give you? 11, right? That's the point. 3, 3, 5. Okay. And so on. And let me do one more and then we'll say and so on. So how would you do 12 cents? Well, that would just be 4 3-cent stamps. So 3, 3, 3, 3. Okay. So, and then this goes on forever, right? And so in order to do this, you need strong induction. In order to prove that that goes on forever, you need strong induction. Okay. So there's a pattern to this. And you can actually prove that any postage, 8 or more, can be made. From, what is it, 3 and 5-cent stamps. All right. So I I mean, hopefully you get the idea, right? We've only got 3s and 5s, but we're saying you can make any number 8 or bigger out of 3s and 5s. Okay, and that's what we're going to be trying to prove. Now, the general strategy for this is as follows. So there's going to be a certain number that you have to show direct, and then after that, there's going to be a pattern. So the trick is this. Maybe I'll try to write the trick here. Okay. So there's a trick to this. To like how to organize the proof. The main idea that you need, and I'm being very kind of like long-winded about this because these problems are problems that people tend to really have trouble with when they try them on the homework, and so I'm trying to do as much as I possibly can here to help you out. So there's a trick to this. The main idea is this. Is that if your smaller stamp is known, right? So 3 cents. That's what our smaller stamp, right? So this is what changes for all of them. Your smaller stamp is 3 cents. Then you will need to show 3 postages in your base case. Your basis case. But only 3. And again, why is it 3 here? The reason it's 3 is because you have 3-cent stamps and 3 postages, only 3. Okay, so that's what you would need. So if your smaller stamp was like 5, then you would need to show 5 things in your base case. Okay, so that's something that you need to understand. Now, why would you need to do that? Well, the reason you only need 3 is because of this. Why 3? Because if you knew that, let's say, postages, let's say 8 cents, 9 cents, and 10 cents are possible. Right? So let's say we just do those 3, 8, 9, 10, right? Which we actually did up here, by the way, right? We did 8, 9, and 10. You know, a 3 and a 5, 3 threes, and a 2 and a 5. So you did those. But you don't actually have to think about how to make 11, right? The reason you don't have to think about how to make 11 is because if you wanted to make a postage of 11 cents, you could just take the 8-cent stamp, and we know our smallest stamp is 3, so you could just do a plus 3, right? One extra stamp, and that'll take you to 11. Okay, and so that's kind of the idea here, because if you've got 8, 9, or 10, you know those are possible. Then if you just add one 3-cent stamp to each of these, so add one 3-cent stamp to each, and you get 11 cents, right? If you add a 3 to the 11, sorry, if you add a 3 to the 8, you get 11. If you add a 3 to the 12, why can't I talk? You add a 3 to the 9, you get 12. And if you add a 3 to the 10, you get 13. Right? And then once you have those, you can add another 3-cent stamp. To each, and you get, what do you get? You add a 3-cent stamp to 11 and you get 14. You add a 3-cent stamp to 12, you get 15. And then you add a 3-cent stamp to 13 and you get 16. Okay, and so on. So the idea here is it's got to be 3 that you have to show, because when you take your first, right here, when you take your first value that you're able to do, the 8, and then you add your smallest stamp, so your smallest stamp was 3, that's going to take you to 11. So you go from 8 plus 11, sorry, 8 plus the small stamp of 3 takes you to 11. So you know how to get from 8 to 11. But what about 9 and 10, right? Because you go from 8 to 11, we skip to 9 and 10. So you actually have to show those directly. And that's why it ends up being that same number. So, right, Y3, because you need to do 3, so then when you add a 3-cent stamp, you're not missing any numbers. Okay, so that's why. And so that is how it is. So if you saw a problem like this and it was like a 13 stamp, if it was if it was values 13 and like 15-cent stamps, you'd be sad because 13 and 15 or 13 and whatever would make you have to show directly 13 different values that you have to do by hand, and that would be a pain. But 3, 4, 5, 6, 7, smaller numbers are easier because it's less work. All right, again, so the smaller stamp tells you how many things you have to do in your base case. Okay, so our strategy for this problem is going to be as follows. Strategy for stamps. Problems. All right, so the first step is kind of optional here, but we'll do it. So first thing to do is figure out the minimum postage that you can make. So you need to show, like basically find and prove which postages can be made for, or with, I should say, in and m-cent stamps. All right. So the first thing is a note, actually not something to do. One note. So one thing that's maybe not obvious is that you can't actually make any postage from any stamps, right? Like if I had 3-cent and 6-cent stamps, I would be in trouble because the 3 cents and the 6 cents both have a 3 involved. And because of that, I'm never going to be able to make a postage that doesn't have a 3 involved. So you can only make 3, 6, 9, 12, right? There's no way to make like 16. There's no way to make like a 16 out of this, right? There's no way to make a 14 out of this, I think. So there's certain values that you can't make if the stamps have something in common. So the GCD of N and M needs to be 1, I think, for this to work. Hold on a second. The app's too laggy right now. All right. Yeah, we're good. So yeah, so the GCD needs to be 1 for this to work out. Okay. So oh, I wrote in and 5. In and in. All right. So like you couldn't do 3 and 5 because they have a 3 in common. You couldn't do let's say I'm trying to think of another number here. You couldn't do 8 and anything that has a 2 in it. So like you couldn't do 8 and 10. That wouldn't work because they have a 2 involved. So you can only make even numbers out of 8 and 10. Okay. Uh, so yeah, that would not work out. But if you did like, let's say, 7's a prime number. So seven's fine with any other number. So you could do like 7 and 10. That would be fine because they have nothing in common. Uh, and you'll see that what the book does to make it easy on themselves is they just pick one of them to be a prime number. So you'll see like 5, and then any number they want here doesn't matter. So they can use a 6, 7, 8, 9, 10, 11. Well, no, not 10, but like 6, 7, 8 would all be fine. 9 would be fine. Etc. So again, the point is that doesn't work because they have a 3. That doesn't work because they have a 2. Uh, but the other two examples are fine. So the greatest common divisor, that's GCD, needs to be 1 for this to work out. But you don't need to care. They'll worry about that, right? So in the problems, of course it's fine. I'm just letting you know in case you're coming up with your own numbers. Um, if you tried to come up with your own numbers, that's the restriction that you have to have. Okay, so here's what you're going to do. So first of all, what postages can you actually make? So the postage you can actually make is this. So the postages that you can make start at n minus 1, m minus 1. Okay. Let's do a concrete example. So like for what did we have? Did we have 3 and 5? Is that what we were using? Yeah, 3 and 5, right? 3 and 5. Okay. So for 3 and 5 cent stamps, it was 3 minus 1, which is 2, times 5 minus 1, which is 4. You multiply that out and you get 8. And then that's where they say postages 8 and more can be made. All right, so that's where you get that number. Again, that's provided it meets that requirement in number 1. You don't have to worry about that, but it is a requirement. All right, so n minus 1, m minus 1. So you just subtract 1 from the stamps and then multiply them. All right, then what you're going to do is starting at that value, at whatever value is the starting value, from part 2, what you're going to do is you need to directly show. So you do it by hand. Um, directly show uh, I'm trying to figure out how to write this. Okay. So we know if the smaller stamp, right? So if the smaller stamp size is in, that's one of those without loss of generality type things. I don't know if in or m is smaller, but I don't want to write it both ways. So I'm just saying assume smaller size is in, right? So if the smaller stamp size is in, then starting at the value from part 2, the number from 2, show directly, that's by hand, that the next, the in postages can be made. And I'm not going to say that more, in more detail right now. Just see the examples, right? For our example, right? So we know it's 8 or more, and the small stamp is 3. So this is your basic case. You show 8 equals something, 9 equals something, 10 equals something. And then that's all you need, right? So you start at the number from part 2. Part 2 gave you that. But then in is the smaller stamp, so you need to do in of these. Okay, enough of that. So then once you're done with that, then what you do is for your induction step, you basically just say, add a small stamp. Actually, that's not true. So for your induction step, you assume all postages, K or smaller, can be made. Right? Plus one extra assumption that's hard to explain here, but I will in the example. Again, see example. So what you're going to do is you just say add one small stamp to the value. This is going to look weird, but k plus 1 minus n to get value k plus 1. Okay, now again, I need a little bit of an explanation here, right? So to show, let's say value k plus 1 postage. So we're doing this in general, right? So to show value k plus 1 postage, can be made from 3 and 5 cent stamps, here's what you have to do. How do you do it? So it's a little bit awkward to write. So you're trying to show value k plus 1. You've already assumed that all postages k or smaller can be made. So k or smaller is already taken care of. We're looking at k plus 1. So how do you do it? Well, the small stamp is 3, right? So what you do is you say, since k plus 1 minus 3 right, so k plus 1 minus 3, and so this is your small stamp value right here, whatever that is. Got to know it. So small stamp value, what do you get when you do this? Well, k plus 1 minus 3 is going to be k minus 2, but that's only for this problem, k minus 2. So since k plus 1 minus 3 equals k minus 2, and that's smaller than k, we know that you can make k minus 2 postage. Right? Because it's smaller than k, you can make that postage because that was the induction hypothesis. So just add a 3-cent stamp to that postage, and you will have k plus 1 postage. Right? So we did it. That was what you were trying to do in that step. So that's really kind of awkwardly written. That's the part that people don't understand. But we'll see how it looks. All right. Once you do that, though, you're done. So you're just going to make a conclusion. You're just going to say, therefore, we can make any postage. What was it? It was like n minus 1, m minus 1, or more. From n and m cent stamps. All right. Yeah. So that's kind of a pain. This middle step here, right? The induction step, that's the part that's tricky here. Okay. So you really want to kind of write it in the same way every time. And hopefully that'll work out. So I'm going to do this one proof. I know that it's tricky here. So let's try this. So we're going to try this for a full example now. Example: prove that every postage 8 or more can be made from 3 and 5 cent stamps. All right. So here's how you do it. So proof, basis case. Basis. What's your basis? So we know that we're starting at 8. So literally, you just have to list out how to make 8, 9, 10, right? So you say 8 cents is 2. No, it isn't. Is 1 3-cent stamp and 1 5-cent stamp. Okay, you don't have to write it that way. I'm just kind of writing it out this way instead of 1 times 3 plus 1 times 5. And we do the 9. 9 cents is 3 times 3-cent stamps. 10 is going to be 2 times the 5-cent stamp. Okay, right? And we know that that's all we have to do because the small stamp is 3, right? So 3 because small stamp size. Okay, so you do that. Once you do that, you go to your induction step. So what's the induction step? All right. So another thing you want to do is because we already did 8, 9, or 10, that means the next one that you need to do is 11. So what you do is you say, assume there's kind of two facts here. And here's the one thing I didn't explain up above that I should have. So assume that, first of all, K is 10 or bigger, and that all postages from 8 up to K can be made from 3 and 5-cent stamps. Right, now pay attention to the numbers here. Like these are going to change for everything, right? Like this is 10 because that's where we stopped here, right? This is 8 because that's where we started here, right? So those are those numbers. Now, the reason we need K to be 10 or larger is because we want K plus 1 to be not one of these, right? And so if K is 10 or larger, right, that means this is the smallest K could be. So K plus 1 must be 11. So it must be the next one. And so that's why we have to do this. And the reason we have to do it is because we need to say add a 3-cent stamp to K plus 1 minus 3, which means we need K plus 1 minus 3 to be 8 or bigger. And so these numbers are set to work out to make that happen, okay? To make it so that the little details of the proof actually work out. Okay, so assume K is 10 or larger and that all postages from 8 up to K can be made from 3 and 5-cent stamps. So what we need to show is that K plus 1 postage can be made. So to make K plus 1 postage, here's what you do. To make actually, let's consider postage K plus 1. You don't have to write it this way. This is just hopefully easy to understand. So we're trying to make postage K plus 1. Since K plus 1 minus 3 is what? K plus 1 minus 3 is K minus 2 is how big? 8 or more. Right, isn't it? K plus 1 minus 3 is 8 or more because we know that K is 10 or larger. So if you put a 10 there, 10 minus 2 is 8 or more. Since K minus 2 is 8 or more, we can just, we have, well, what do we have? So it's 8 or more. So it's 8 or more, so it can be made. Postage K minus 2 can be made. By the induction hypothesis. Right? Because it's 8 or more. Actually, I want to say this. I wanted 2 facts here. So K minus 2 is 8 or more. So K minus 2 is 8 or more. And also, k minus 2 is smaller than k, obviously, because it's minus 2. So if it's 8 or more and smaller than k, then the induction hypothesis says you can make postage k minus 2. So you can make postage k minus 2. So once you have postage k minus 2, you add a 3-cent stamp to it. So to get postage k minus 2 plus 3, which is k plus 1. So we made postage k plus 1 out of postage k minus 2. You add 3 to it. Yeah, and that's what we were trying to do, because we were trying to make postage k plus 1. So postage k plus 1 can be made. And that's what we were trying to do. So then you can make your conclusion, which is simply, I'll say by strong induction this time, but you don't need to. You can just say, by induction or whatever. By strong induction, all postages, 8 or more, can be made from 3 and 5-cent stamps. Ugh. All right. So that's the idea. Now, so that's the end of the proof. What can I say about it? You can see that all the stuff that's hard to understand is probably in this middle section right here. This is where the work is. And I don't really know how to explain it better than I did. So you just have to, think about this, right? The numbers are set up to make it work out, right? So this is the key here. You're trying to make postage k plus 1. So if you subtract the small stamp away from k plus 1, you get a different number, k minus 2. Well, that number is set up to be 8 or more. So it's 8 or more, right? Which means by this, all postages 8 up to k can be made. So we know that it's 8 or more and it's smaller than k. So that means it's from 8 up to k, which is our induction hypothesis. So the numbers were rigged so that k plus 1 minus the small stamp is in this section here, 8 up to k. All right. And that's what makes the whole thing work out. And so the numbers change from problem to problem, but that's how you construct one of these proofs. Okay, so that's as long as I want to go today. We're going to do more of these later on in another video. All right, that's it.